In this video, I will solve a micro 2 problem, an intermediate micro problem that for Cournot model. And I guess the best it can be described is asymmetric Cournot model. So we will have our inverse market demand is 20 minus 2 capital Q, where capital Q is the total quantity produced by two firms. And for firm 1, its costs are, it has constant marginal cost of 2. And firm 2 has a constant marginal cost of 2 plus x, where x is some parameter that takes some values. So in this problem, we will solve it for any x. And then if you want to find equilibrium and equilibrium outcome for different values of parameter x, you could just plug in those values. So let's start with setting up profit functions. So profit function of firm 1 depends on quantity produced by firm 1 and quantity produced by firm 2 in the following way. So firm 1 will sell, if it decides to sell Q1 units, it will sell Q1 units. The price will be given by 20 minus 2 times Q1 plus Q2. So that's revenue, and then minus the cost of firm 1. So if we work on it and simplify things, we will get Q1 18 minus 2Q1 minus 2Q2. So that's the profit function of firm 1. And we can, once we get this profit function, we can start building our best response. To get best response, we want to maximize this profit with respect to Q1. So we're picking Q1 greater or equal than 0. So for that, we'll take a derivative of the profit function. So find first order condition, which will be 18 minus 2Q1 minus 2Q2 minus 2Q1. We set it equal to 0. And solve it such that Q1 is on one side and everything else is on the other side. So it will be 4Q1 equals 18 minus 2Q1. Therefore, our best response of, let me write it somewhere here. So best response of firm 1 as a function of Q1 is, it will have two branches. So the one, first of all, the one given by this formula will be, what's that, 4.5 minus Q1, its best response as a function of Q2. Q2 divided by 2. So that will apply as long as Q2 is less than 9. Because when it's less than 9, this is a positive number, but once Q2 is greater than 9, then we will run out. So it must be 0. Of course, we have this restriction here when Q2 is greater than 9. Okay. So that's the best response of firm 1 as a function of Q2. Now let's quickly do the best response for firm 2. It will look slightly differently. So increase this part. I'll just do it much quicker. So our profit 2 again will depend on Q1 and Q2. And now it will be Q2 18 minus 2Q1 minus 2Q2 minus the cost. So 2 plus x Q2. Therefore, overall it will be, sorry, it's not 18, it's 20 here. So then it's 18 minus x minus 2Q1 minus 2Q2. We'll set up the same problem, maximize, take a derivative, to get the best response function of firm2 as a function of Q1, which will be, so effectively it's the same problem, it's just 18 is minus x, therefore this branch will look differently. It will be 4.5 minus x over 4 minus Q1 over 2. And it will be 0 here. And now all we need to figure out is the solution at which it works. So for Q1, that is just when this turns into 0. So if we multiply everything by 2, we'll get 9 minus x over 2 equals Q1. So so as long as our Q1 is less than 9 minus x over 2, firm2 will reply with positive number, and as long if Q1 happens to be greater than 9 minus x over 2, then best response for firm2 is to produce 0. Okay. Okay. So now let's once we have two best response functions, we can solve for the Nash equilibrium here. So let's solve for the positive Nash equilibrium first. So just the logic of Nash equilibrium here will be, note that firm1 will always produce here, because firm1 is always at least as good as firm2, and for most of the parameters x, firm2 is less efficient. So we'll have two types. Either both firms are producing, or if x is high enough, then firm2 can become too inefficient, and therefore it will decide to not to produce, and then firm1 will produce monopoly output. We will get it from our best response functions. Okay, so let me erase this part. And so let's solve for Nash equilibrium. So Nash equilibrium is the one where Q1 and Q2 both will be positive. So we will derive the condition on x for that, but effectively we have then Q1 must be best response of firm1 given Q2, and Q2 must be best response of firm2 given Q1. So we solve two equations here. Q1 equals best response of firm1, 4.5 minus Q2 over 2, and Q2 must be 4.5 minus x over 4 minus Q1 over 2. So this is the system of equations that needs to be solved. Okay, then let's just, so anyway, so you cannot use symmetry argument here because firms are asymmetric, so you actually have to solve the system. I mean, the easiest is usually just to, for example, plug this one into here, get one equation of Q2, and work your way through it. So let's do that. So Q2 equals to 4.5 minus x over 4 minus, and instead of Q1 minus 1/2, I plug in 4.5 and minus Q2 over 2. So the next useful thing to do will be to multiply everything. Let's multiply everything by 4. So that's 9, so that's 18 minus x minus 2, 4.5 minus Q2 over 2, or 18 minus x minus 9 plus Q2. Okay, and as a result, we get okay. So I'll just go in this direction here, I get 3Q2 equals to 9 minus x. So my Q2 is 3 minus x over 3. So once I get this, I can simply plug it in here. So my Q1 must be then be 4.5 minus 1/2. I'm just plugging this value into here, minus 1/2 plus x over 6, so it's 3 plus x over 6. Yeah. And therefore we have our Nash equilibrium. So let me erase this part here and just figure out. So Q1 is 3 minus x over 3, Q2 is 3 plus x over 6. So this is where we do equilibrium, because we see that as from 2 gets less efficient, when x starts to rise, from 1 will okay, sorry, messed it up. Q2, Q1. 1 will produce more, and 2 will produce less. Okay, so now we can solve, so that's one Nash equilibrium. So the other one, that will be true for small x, but when x gets large, we can see that Q2 will start getting, at about 9, it will turn into 0. So effectively, we need to solve for another one. So this one holds together if x is less than 9. So notice that when x is 9, this firm will produce how much? Basically, it will produce exactly, guessing this quantity. And so as a result, best response of firm 2 will be to stay out at that point. So yeah, let me erase best response. I don't think we need it anymore. So that's one Nash equilibrium for x less than 9. For x more than 9, we will have Q2 being 0. And then we can use best response of from 1 to figure out what from 1 will be producing. Notice that you cannot use this formula. You just, because it's only applies to this case. It's incorrect formulas when x gets large, such that this quantity turns into negative number. So you cannot simply use it. You actually have to go back to your best response. And best response says if the other firm is producing 0, then from 1 should produce 4.5 in this case. So that's Nash equilibrium of this model for parameter value x greater than 9 and above. Okay. Once you've done it, so one other thing we need for solving this question is a perfectly competitive outcome, because we will be comparing Cournot model to perfect competition. And perfectly competitive outcome. So here it's very easy. You have two firms, and one of them is efficient. The other one, for any parameter x, is not efficient, unless x is 0. But for perfect competition, it wouldn't matter, because the marginal cost of perfectly competitive firm, is 2. So its marginal cost is 2. So when firms in perfect competition environment, we just supply at marginal cost. So it's just 2. Our demand looks like this. It's 20 minus 2Q. So in a perfectly competitive outcome, we will have P equals to 2, Q star quantity will be effectively what? 9? Of course, that's what it is. And it's price, your quantity here. So that must be 20. And what else do we need to calculate? So producer surplus here is just profits. Obviously, with the constant marginal cost, profits will be 0. So consumer surplus is just this area, this triangle. So it's 1/2 18 times, this is 9. 9, so it's 81. And so social welfare here is 81. So that's what we will be comparing against. So I'll just do one of the cases. So in this problem, we actually asked to solve the Cournot model for different values of parameter x, for x equals 0, for x equals 6, and for x equals 12. So let's just quickly do it. So when x is 12, this is the easiest one, is we already know what it will be. So Q1 will be 4.5, Q2 is 0, total quantity produced will be 4.5, price will be, you can just plug in, is it 20 minus 2Q. So if total quantity is 4.5, then 9, so 11. Then the price will be 11, and you can calculate the rest. Profit. Well, profit is 0, 1 will be something, and you can calculate the weight loss relative to that. When x equals 0, it's a symmetric model. So when x equals 0, it's symmetric equilibrium. Q1 equals to Q2 equals to 3, total production will be 6, price will be 8. Price will be 8, and profits of the two firms will be identical, and what would they be? So they each sell 3 units. 8, that's 24, minus 6, so it's 18. So producer surplus then is 36. Consumer surplus. The price will be at 8. At 8, so it will be consumer surplus is 1/2 times 12 quantity sold. Total welfare in the case is 72, and we can see that the weight loss is 9. Of course, total welfare must be 81, but the model is just 72. And the case with x equals 6, it will be developing through the end, but you can just obviously weigh in this case, so both frames will be producing. Then Q1 will be 4, and Q2 will be 1. Total quantity will be 5, and the price will be 10. And you can calculate the rest. So here it's a little bit more calculations. So hopefully this is enough to solve this problem and work your way through this problem. Thank you.